standard we have learned about grouped as well as ungrouped frequency distribution. Moreover, we have learned how to convert the given data into pictorial representations such as histograms and frequency polygons. Also, we have learned how to calculate measures of central tendency like mean, median and mode for ungrouped data. Now, in this chapter, we are going to learn how to calculate mean, median, mode for grouped data. So, grouped data is nothing but condensing the raw data into small class intervals, small groups. So, we are going to learn in this video how to calculate mean using three methods. There are three methods for calculating mean. The first method is called as direct method. The second one is called as assumed mean method, and the third one is called as step deviation method. So direct method can be used when the numerical values of the given observations are too small. When the data is too large, then we can use either assumed mean method or step deviation method. Now, what is mean? Mean is nothing but average of given observations. If ungrouped data is given, we calculate the mean by adding all the given observations and then dividing by total number of observations. Now for grouped data, we have to find the class mark. F1, F2, etc., Fn, which means x1 is repeated F1 times, x2 is repeated F2 times, and so on. Then we can get the sum of the observations as F1x1 plus F2x2 and so on, Fn(xn). And total number of observations is obtained by adding all the frequencies F1 plus F2 plus etc. Fn. Now, mean of the grouped data is obtained using the formula x bar equals to sum of the observations divided by total number of observations. In short, we can write this as sigma fi xi by sigma fi I ranging from 1 to n. The sigma is nothing but Greek letter which represents summation. Also, we can write in short as sigma fi xi by sigma fi. Now we will learn how to calculate mean by applying direct method. So let us consider this example. The following table gives the number of pages written by Sarika for completing her own book for 30 days. Find the mean number of pages written per day. So here it's given 16 to 18, 19 to 21 are the class intervals. Wherein the frequencies are given, corresponding frequencies 1, 3, 4, 9, 13 are given. Now observe these class intervals. These class intervals are not continuous. So it is from 16 to 18, then next one is starting from 19 to 21. So we have learned in 9th standard how to convert these class intervals to continuous class intervals. So what we need to do is, we need to subtract 0.5 from the lower limit and add 0.5 to the upper limit. So here 16 minus 0.5 will give you 15.5, 18 plus 0.5 will give you 18.5. Similarly, next one, 19 minus 0.5 is 18.5, 21 plus 0.5 is 21.5. So now the class intervals has become continuous. So continuous in the sense, the upper limit of the first class interval is the lower limit of the next class interval. So the class intervals has been converted to continuous class intervals. And now we find the class mark. So class mark is nothing but the average of lower and upper limits. So 15.5 plus 18.5 will give you 34. So 34 by 2 will give you 17. So here the limit value is 20. For this class interval it is 23 and so on. So then find product of frequencies and the corresponding class marks. So 1 into 17 is 17, 3 into 20 is 60, 4 into 23 is 92, 9 into 26 is 234, 13 into 29 is 337. So now by adding all these FIXI values, we will get sigma FIXI, which is 780. And sigma FI is already given as 30. And Now by direct mean method, mean is calculated using the formula sigma fi xi by sigma fi. Sigma fi xi is nothing but 780 divided by sigma fi is 30. So when we divide, we are getting the mean as 26 for the given frequency distribution. So hence the mean number of pages written by Sarika per day is 26.
Let us begin with the direct method. What do the two columns in this table represent? The first column represents the class interval of group data, and the second column represents the frequency for each class interval. The first step to finding the mean of grouped data using the direct method is to find the class mark for each class interval. Let's denote the class mark as xi. The xi for each class is equal to half the sum of the upper and lower class limits of each class interval. Using the formula, we can calculate the class mark for each class interval. The class mark for the first class interval is equal to half the sum of 5 and 25. That is, half of 30, which is 15. Similarly, the class mark for the second class interval is 35. The remaining class marks are calculated and given in the table. Next, let us find the product of the frequency and the class mark for each class interval. This is denoted by fi xi. Now observe carefully how we calculate the value of fi xi. As you observed, for the first class interval, fi xi is the product of 12 and 15, which is equal to 180. Similarly, for the second class interval, fi xi is 280. The remaining products are shown in the table. Now, let us find the sum of the products of the frequencies and the class marks for all the class intervals. This sum is represented by summation fi xi, which is equal to 3300. We are close to finding the solution for Miss Greenfinger's problem. The mean x bar of this grouped data is equal to the sum of the products of the frequencies and the class marks for all the class intervals divided by the sum of all the frequencies. On calculation, we get the mean of the given grouped data as 55.
In the previous sum, we have seen that the values of xi and fi are too small. So the product was easier. Calculating the product of fi and xi was easier. So now, there are situations where the values of xi and fi are large. Then finding the product of fi and xi will become tedious and time consuming. So in order to save time, we have another method known as assumed mean method, wherein the frequencies will remain constant. We can't change frequencies, but we can reduce the class marks to a smaller values. So we are going to do, with the help of an example, we are going to learn assumed mean method. Thereby, in this method, we are going to reduce the calculation part. We are going to simplify the calculation part by reducing the values of x's. So we consider an example of understanding the assumed mean method, or otherwise called a shortcut method, using with the help of this example. The marks obtained by 30 students of class 10 of a certain school in a mathematics paper consisting of 100 marks are presented in the table below. Find the mean of the marks obtained by the students. So the marks obtained are given and number of students we assume it as frequencies. So as I told, frequencies will remain fixed, and since it is grouped data, we have to find the class mark. So class mark is obtained using the formula upper limit plus lower limit by 2. Say for example, the class mark for the first class will take 25 is, so a lower limit plus upper limit by 2, 10 plus 25 by 2, which is 35 by 2, which is nothing but 17.5. So this 17.5 is obtained by adding 7.5 to the lower limit. So this is a technique for calculating the class marks for the other class intervals. So now 25 plus 7.5. The will give you 32.5. Now 40 plus 7.5 is 47.5. 55 plus 7.5 is 62.5. 17 plus 7.5 is 77.5. 85 plus 7.5 is 92.5. So now we can observe that these values are larger. Then finding product and simplifying, finding mean will become difficult. So in order to simplify the calculations, we are going to calculate deviations. We are going to simplify only x's. Fx will remain always constant. So we choose a value, the middlemost value as a, which is known as assumed mean. So taking the middle values, here you have two middle values. Since there are 6 x's, you can either choose 47.5 or 62.5 as the value of a, which is called as assumed mean. And then we need to calculate the deviation of all these x's from this a. So we are going to find the deviations of a from all these x's. So the deviation of a from x1, so 17.5 minus 47.5 will give you minus 30. Then 32.5 minus 47.5 will give you minus 15. 47.5 minus itself is 0. Then for 62.5 minus 47.5 is plus 15. Then plus 30 plus 45. Yes? And now we have calculated the deviations. Now we will find the product of frequencies and the deviations. So now we have simplified the exercise by calculating the deviations. Now product of 2 and minus 30 is minus 60. 3 into minus 15 is minus 45, and this will be automatically 0. 6 into 15 is 90. 30 into 6 is 180. 45 into 6, 6 5 30, 270. So now add the negative integers, which will give you minus 105. Add the positive integers, which will give you 540. So find the difference. So you get 540 minus 105. 435. So sigma Fi di is nothing but 435 and sigma Fi is 30. So now by assumed mean method, mean is calculated using the formula x bar equal to a plus sigma Fi di by sigma Fi. So here a is nothing but the assumed mean, which is 47.5 plus sigma Fi di is 435 divided by sigma Fi is 30. So we can either take LCM and simplify, or we can find a fraction value. We can convert this into decimal and then we can add. So first we can simplify with 5 table. Plus, so when we divide 87 by 6, we are getting 14.5. So this is nothing but 62. So therefore the mean marks obtained by the students is 62. So we have learned how to find mean using assumed mean method using the formula x bar equals to a plus sigma Fi di by sigma Fi. How did we obtain this formula? So let us try to understand. Now by direct method, we have learned you can find mean using the formula x bar equals to sigma fi xi by sigma fi. Now similarly, mean deviations can be calculated using the formula sigma fi di by sigma fi. For x bar it is xi, for d bar it is di. So now we will replace di. Already we have learned the sum. Di's are nothing but deviations which are obtained by subtracting a from the xi's. So just we are replacing di with xi minus a by sigma fi. And now we can split the bracket terms. So sigma fi into xi minus a into sigma fi. Because a is constant, we can take out a. Divided by sigma fi. Now splitting the numerators and denominators, we get sigma fi xi by sigma fi minus a into sigma fi by sigma fi. Now from this we have sigma fi xi by sigma fi as x bar. So we are replacing this with x bar. Then after cancelling the sigma fi, we are left with a. So d bar is nothing but x bar minus a. By transposing a this side, we get d bar plus a equals to x bar, or x bar can be written as a plus d bar. But d bar is nothing but sigma fi di by sigma fi. So this is how we have obtained the formula for assumed mean method. The mean obtained by all the three methods would be the same, but only thing is the second and third method, assumed mean method and step deviation methods, are the simplified forms of direct method. So now we will learn how to apply step deviation method with the help of this example. The table below gives the percentage distribution of female teachers in the primary schools of rural areas of various states and union territories of India. Find the mean percentage of female teachers by any suitable method. So we are going to find mean using step deviation method. So here again we are going to find class mark. Class mark is nothing but mid value of each class interval. So mid value of 15 to 25 is 20, 30. The next one is 40, 50, 60, 70 and 80. And now just how we have found deviations in the previous sum, the same manner we are going to find the deviations. Now here the middle value is 50, so we assume this as the value of a, which is assumed mean. Then we have to find the deviations of all the xi's from a. So this value, deviation of 50 from itself is 0. Then deviation of 40 from 50 is minus 10. Deviation of 30 to 50 is minus 20. Deviation of 50 from 20 is minus 30. The values, the deviations above 50 will be always negative. The values of deviations below 50 will be always positive. So now the same values will be repeated, but they will be positive. 10, 20, 30. So now, since the deviations are multiples of 10, we can furthermore simplify the deviations. So which will give us the value of ui. So ui is nothing but di by h. H is nothing but class size. Class size is nothing but upper limit minus lower limit. So upper limit minus lower limit is nothing but 25 minus 15, which is 10. So here the value of h is 10. So all these values are divisible by 10. So we will divide these deviations with 10. So here 0, minus 1, minus 2, minus 3. Here 1, 2 and 3. So we have simplified the class marks by finding the deviations and dividing by the class size. So now multiply the values of fi and ui. So F1 into u1 will give you minus 18, then minus 22, minus 7, 0, 4, when 2 into 2 is 4, and 1 into 3 is 3. Now adding all the negative integers, you get minus 47 and here plus 11. So sum of all these values will give you a value of sigma fi ui. So minus 47 plus 11 will give you minus 36. Now sigma fi is sum of all the frequencies. So you get and now we apply the step deviation method. So formula for step deviation is x bar equals to, usually we represent mean by x bar. So by step deviation method, x bar is a plus sigma fi ui divided by fi into h. So a is nothing but the assumed mean, which is 50. Sigma fi ui is minus 36 by sigma fi is 25 into h, class size is 10. So now we will simplify. So plus into minus is minus. So we can cancel it. So we get 50 minus 72 by 7. So we can find the decimal form. So which will give you 39.72. So therefore, the mean percentage of female teachers is 39.72. We have used the formula x bar equals to a plus sigma fi ui plus sigma fi into h for calculating mean using step deviation method. Now we will try to understand how we have arrived at this formula. So u bar can be obtained using the formula sigma fi ui by sigma fi. Just as how we got x bar as sigma fi xi by sigma fi. So here for x bar you have xi, for u bar you have ui. And ui is calculated by dividing the deviations with h, where h is the class size. But deviations are obtained by subtracting a from xi minus a by h. And now u bar equals to sigma fi ui by sigma fi. Now we replace ui with xi minus a by h, the whole thing divided by sigma fi. Now since h is constant, we can take away the h, that is 1 by h, out of the bracket. Then we have sigma fi into xi by sigma fi minus a into sigma fi by sigma fi. So what we have done, here h is a constant, since it is in the denominator, 1 by h we can take it out. Then we have sigma fi into xi by sigma fi minus a into sigma fi by sigma fi. So now this is nothing but 1 by h into sigma fi xi by sigma fi is nothing but x bar minus, after cancelling here you are left with a. So here by transposing h this side, since it is in division it becomes multiplication. You have on RHS x bar minus a. Now transposing minus a this side, you will have a plus u bar h equals to x bar. So x bar is nothing but a plus h into u bar. H into u bar is nothing but sigma fi ui by sigma fi. So this is how we have derived the formula for finding mean using step deviation method.
Observe the class intervals in this table carefully. Note that the class size for all the class intervals is 20. The class size is the difference between the upper class limit and the lower class limit. It is denoted by the letter H. Now for each class interval, let us divide the deviation from assumed mean by the class size. This value is denoted by UI. The value of UI for the first class interval is equal to minus 20 divided by the class size 20, which is equal to minus 1. Similarly, for the second class interval, this value is 0. The remaining values are shown in the table. Now, let us find the product of UI and the frequency Fi for each class interval. This is denoted by FIUI. For the first class interval, this product will be equal to 12 into minus 1, which is equal to minus 12. Similarly, for the second class interval, this value will be 0. The remaining values are provided in the table. Now, let us add the products of Fi and Ui for all the class intervals. This value summation FIUI in this case comes to 60. Now, let us see how we can use this value to find the mean of the given grouped data. This involves a bit of derivation. Let us start with the relation we found in the assumed mean method. Since Ui is equal to Di divided by H, we can say Di is equal to the product of Ui and the class interval H. Substituting this value in the equation, we find a relationship between the mean x bar, Ui and H. Further substituting in the values, we find that the mean of the given grouped data is 55. This method is called the step deviation method.
Now we will learn how to find the missing frequencies using any of the three methods for calculating mean. We have learned DAG method, assumed mean method and step deviation method. We can use either of the methods for finding the missing frequencies. So we will try to understand how to find missing frequencies by using either of the methods through this example. So consider this example. The following distribution shows daily pocket allowance of children of a locality. The mean pocket allowance is 18. Find the missing frequency. So here the missing frequency is F. We have to find how many children are having a pocket money as rupees 19 or 20 or 21. So now I prefer usually step deviation method because in that the calculation part will be easier as we simplify exercise. Okay. So now we will calculate class marks which are mid values. So mid value for the class number 11 to 13 is 12. For the next one it is 14, 16, 18, 20, 22, 24. So here usually we prefer the middle values as a sheet mean, but it is not compulsory because mean doesn't depend on A. You can choose any of the values, but to make the calculations easier we choose the middle values as the value of A. But here you can choose the value which is near to F as A value. So I am choosing this 20 as the value of A. So then deviation of 20 with itself is 0. 18 minus 20 is minus 2. then -4, -6, -8. So usually the value of deviations above the value of A will be negative and below it will be positive. Then here it is +2 and here it is +4. So now all these are multiples of 2. So here we take H as 2. Also the class size is also 2. So now by dividing all these values with 2, we'll get -4, -3, -2, -1, 0, 1 and 2. So now we will find the product of Fi and Ui. So 7 into -4 is -28, 6 into -3 is -18, 9 into -2, -18, -13, then 0, then 5 and then 8. And now we can add all the negative integers. Since all are negative, we can add and put minus sign. By adding all positive integers, you are getting it as +13. So -77 plus 13 will give you -64. So sigma Fi Ui value is -64. And here sigma Fi value, since F is the unknown quantity, you have to write F separately and add rest of the values. 13, 22, 34, 44, F plus 44. So now by step deviation method, we can calculate mean using the formula A plus sigma Fi Ui by sigma Fi into H. So here already the mean allowance is given as 18. So substitute it as 18 and we have chosen A value as 20. 20 plus sigma Fi Ui value we have obtained as -64 and sigma Fi is F plus 44 and H value is 2. So now bring this transpose 20 this side. 18 minus 20 will give you -2 and then here -64 into 2 will give you -128 by F plus 44. Now cross multiplying F plus 24 with -2 we will get -2F minus 88 equals to -128. So -2F equals to -128 plus 88. So which will give you -40. So -2F is -40. After cancelling both the minus signs, we get F equals to 40 by 2 which is 20. Therefore the missing frequency is 20. Now we will try to find double missing frequencies again using step deviation method. So now consider this example. The mean of the following frequency distribution is 50. Find the missing frequencies if the total frequencies is 120. So now class intervals are given and frequencies are given. We need to find the value of F1 and F2. So as usual, we will find the class mark, which is nothing but the average of lower and upper limit, or which is the mid value of each class interval. So mid value of 0 to 20 is 10, for 20 to 40 is 30, for the next one it is 50, then 70 and then 90. And now as I told you in the previous sum, we need not choose only the middlemost value as A. We can choose either of the values of A since the value of A doesn't affect the mean of the given distribution. So I am choosing 30 as the assumed mean. So here we need to find the deviation of 30 from all the xi's. So the deviation of 30 with itself is 0. 10 minus 30 is -20. I told you the deviations above 0 is negative and below 0 is positive. So here 50 minus 30 is 20, then 40 and 60. So now all these these values are multiples of 20. Also the class size is 20. So H value is 20. So we will divide the deviations with 20. So we get from minus 20 by 20 is minus 1. This is 0. This is 1. 40 by 20 is 2. 60 by 20 is 3. And now we will find the product of Fi and Ui. So we get 17 into minus 1 is minus 17. Next one will be 0. Then 32 into 1 is 32. F2 into 2 is 2F2. Then 19 into 3 is 57. So now adding these positive values we get 89. So now this 2F2 is unknown quantity, so write it aside. Then simplify. Minus 70 plus 89. So when you simplify, you will get plus 72. And here sigma Fi, here F1 and F2 are unknown quantities, so write it aside and add the remaining three values. So you have 9, 18, so carry over 2, 5, 6. Okay, so now by step deviation method, we calculate mean using formula A plus sigma Fi Ui by sigma Fi into H. So meanwhile, we have obtained sigma Fi as F1 plus F2 plus 68. But already it is given that sigma Fi is 120. So here sigma Fi is 120. But according to this, sigma Fi is F1 plus F2 plus 68, whose value is equal to 120. So we have F1 plus F2 equals to 120 minus 68, which will give you 52. So F1 plus F2 equals to 52. You consider that as equation 1. So now consider this formula. X bar equals to A plus sigma Fi Ui by sigma Fi into H. But X bar is already given as 50. So substitute X bar as 50. Now here we have assumed A value as 30. 30 plus sigma Fi Ui value is 2F2 plus 72. 2F2 plus 72 divided by, instead of choosing sigma Fi value as a lengthy expression, we can take the value as 120 as it is easy for us to simplify. Into, what is the H value? It is 20. Now, you can cancel these two because it is in product form. 2 1s are 2 6 are. So now transposing 30 this side, you get 50 minus 30 equals to 2F2 plus 72 by 6. So we have 50 minus 30, which is equals to 20, equals to 2F2 plus 72 by 6. By transposing 6 this side to LHS, since it is in division, it becomes multiplication. 20 into 6 is 120. This is equal to 2F2 plus 72. By transposing 72 this side, it becomes 120 minus 72, which is 48. So 2F2 is 48. So F2 is 24. We have obtained one missing frequency. In order to get the other missing frequency, we need to substitute F2 value in equation 1. So substituting F2 equals to 24 in equation 1. So we get F1 plus F2 is 24, which is equals to 52. So F1 equals to 52 minus 24, which is 28. Therefore, the missing frequencies are F1 equals to 28 and F2 equals to 24. So, in this video, we have learned how to find mean using direct method, step deviation method and assumed mean method. Also we have learned how to find single missing frequency and double missing frequency. Hope you have understood well.